In my previous video, you may have remembered how to do this sort of question where it's asking you to solve an equation where one thing equals another thing by using a graph. And the way that we do this is by graphing this thing where y equals that, and then graphing this thing where y equals that, and then by finding the points where these two lines are equal. So by drawing the line y equals x cubed plus x, we will see that it's the curve that you can see on this grid, on this graph, sorry. And then we would draw the line y equals 6, which would be a line across like this. Ooh, I haven't drawn that very well. Let's do that again. And a bit better. And we can see if we zoom into this bit here, that it would look something like this. And we are drawing a line across from 6 where y equals 6. We're trying to find the x value where that works. And it looks like it should be around 1.7, I guess. And we could try that by putting that into the equation and just checking if it's around 6. So we would do 1.7 cubed plus 1.7. And if we did that, we would find that it's going to be around 6. In example 2, it's asking us to determine where x cubed plus x equals 6 correct to 2 decimal places. Now this, obviously we couldn't have done using the graph. We've worked out that it's going to be 1.7, but we can't really be any more accurate than that. But to get it correct to 2 decimal places means that we've got to try a different approach. And this is called trial and error, or trial and improvement. And we know that it's going to be between 1.6 and 1.7 from the graph. So we're going to try 1.6 by putting 1.6 in. And by putting that in, we'll find that it's 5.696. And our comment here will be that 1.6 was just too small, because this is not 6, it's less than 6. So therefore, when we put 1.6 in, it was too small. So 1.x is going to be less than what x should be. Then we would try 1.7 and just test to see if that was too large. So 1.7 into this function would give you 6.613. And then we'd say, well, we know that 1.7 was too large and 1.6 was too small. So therefore, x would have to lay between these two. So we would write that. We would then pick the midpoint between these two. So we would choose 1.65, and it's important that we always do the midpoint. By putting that in, we'll find that it's 6.142125. I've worked these values out before, by the way, this isn't me doing it in my head. And we'll say that this is too large, so therefore it's going to have to lie between 1.6 and 1.65. It would equal exactly 6. And then we keep going. We'll say, right, well, if 1.65 was too small, let's try 1.63. And putting that in, we'll find that it's 5.96, blah, 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 blah. And that was too small. So therefore, we know that it's going to lie between 1.63 and 1.65. Then we try it again with, let's say, 1.64. That would give you 6.05, blah, blah, blah. And therefore, it's going to lie between 1.63 and 1.64. And now we know that it lies between these two. Which one is it closer to? We could look at these two and decide which one is closer to 6, or we could put in the midpoint between these two and say whether that's too large or too small. And this was 6.005, blah, 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 which is too large, so therefore the 1.63 must have been the closer one. So the comment here could be that 1.63 was too small, but 1.635 was too large. And therefore, correct to 2 decimal places, we would say that x was 1.63 after 2 decimal places, that is the closest x value, which gives us the value closest to 6.